So I want to pick up where we left off yesterday. We're on the water balloon example. This relates to every single problem we did yesterday, right?
Yes.
Yeah.
It was getting very repetitive, but my hope is that it is, burned into your brain and you know how to do it now.
Yeah.
So, okay, a water balloon was thrown from a window. The height of the water balloon over time can be modeled by the function y equals negative 16x squared plus 160x plus 50. What was the maximum height of the water balloon after it was thrown? What is it I'm looking for? I'm looking for the maximum, which is where?
450.
I don't know the number, but it's at the vertex. Okay. Max, okay guys, focus. Max is going to be at the vertex, right?
Correct.
So, what do we have to find before we find the vertex? You are finding the axis of symmetry. Now, axis of symmetry, what's our formula?
X
Negative B over 2 times A.
Okay.
Raise your hand.
Negative b over 2a. Now, I didn't identify my ABCs here. You guys know those by now, right? So, negative b is going to be negative 160 over 2 times negative 16. Negative 160 divided by negative 32 is going to be positive something. 5? That was my guesstimate. Okay, so we have an axis at x equals 5. Is that logical before I proceed?
Yes.
Yeah, that looks like I'm on the right track. If I get some axis that doesn't match up with my picture, then we might want to rethink this. Okay. So, what do I do for the vertex now? Besides math, a little more specific. We know my vertex is the 5. We're going to plug it in. So, negative 16 times 5 squared plus 160 times 5 plus 50. 5 squared is 25. Negative 16 times 25 is negative 400. 160 times 5, 800 plus 50. Negative 400 plus 800 plus 50?
400 plus 50.
450. Okay. Does that make sense?
Yep.
Yeah. Okay, so when we ask what is the maximum height of the water balloon after it was thrown, 450 feet, what is that by?
How many seconds?
Okay, so after 5 seconds, 5 seconds after the water balloon was thrown, it reached its maximum height of 450 feet.
That's a lot of feet for a water balloon.
Okay,
Whose arm?
It's the hog.
not mine. So 5 seconds. After the water balloon was thrown, it reached a maximum height of 450. It is feet, isn't it? Yes. Max height of 450 feet. Okay. Questions on these? I know some of you have tried the homework. If you've tried the homework, you're seeing you're doing a lot of vertex and graphing. Now, we have one other part of this lesson. And to be honest, I really thought about separating this into a whole nother lesson, but I left it as is.
Whoa.
Is it just that?
That's a lot of room to work.
Now, the directions ask us to write an equation of a parabola given 3 points. So, provided 3 xy points, we have to write the parabola equation. So, y equals something x squared plus something x plus some number. Now, I don't think I mentioned it in this class, but I gave my other class a heads up and said, you remember doing systems of 3 equations last chapter?
Yeah. With like the 3 X, Y, Z.
Yeah, where we numbered them 1, 2, 3.
Yeah.
It's back.
Oh!
Okay, it didn't leave for long. It's back. We're going to use these 3 ordered pairs to write 3 equations, and then we're going to solve them. So, once we get the problem set up, the process is the same. The main difference is we have to set the process up. Now, in order to get started, what is standard form of a quadratic equation?
1, 2, 3.
What is standard form of a quadratic equation?
Ooh, y equals mx plus b.
No, that's wrong. Y equals a squared plus b x plus
B, X plus C.
Y equals ax squared plus bx plus c. If you want to volunteer answers, please do so, but give me real answers. Okay? Singing Michael Jackson is not giving me real answers. Just saying. Okay, so y equals ax squared plus bx plus c. Standard form here. Now, in an ordered pair, what are we provided in the ordered pair negative 2, 32? That is an x and a y. Over here, what we're going to do is we're going to take that, what did I say it was, negative 2, 32, and we're going to plug those values in for x and y. And then when we write that equation, it's going to have ABC left. So one of the differences is instead of solving equations that have x, y, z, they're going to have ABCs. So y equals, I'm going to say 32 equals a times x squared, so negative 2 squared, plus bx, so b times negative 2 plus c. I tend to kind of write it out this way, and then I'll clean it up. So if I clean it up, 32 equals, what's negative 2 squared? 4. So this is going to be 4a, b times negative 2 minus 2b plus c. Okay, guys. This is our first equation. We've got 2 more pairs to do this with, yes? And you have to be careful, okay? Watch your signs, watch everything, because unfortunately, again, you make one little mistake. You guys know how these problems go, right? So we have to be very careful. Let's do the same thing with the ordered pair 1, 5. If we're using 1 and 5, these are x and y, right? So y equals means I'm going to start with 5 equals ax squared, a times 1 squared, plus bx, b times 1, plus c. I like this equation. What's this clean up to be? So it's not just 1 plus 1. Don't forget the a's and b's. So 1a plus 1b plus c. Or in other words, I just wrote a plus b plus c equals 5. I just still have my 5 on the other side here for the moment. And repeat the process one more time. This time my ordered pair is 3, 17. We're okay with the setup then, right? Okay. So 17 equals a times 3 squared plus b times 3 plus c. Clean it up, and 17 equals what? 9a plus 3b plus c. Okay, guys. I've got my 3 equations. From here, I'm going to put them together all in one spot. I'm going to number them 1, 2, 3. And then I personally tend to go with elimination here. However, if you really found a liking for substitution, you'd prefer that, you know, it's kind of your choice there. So, let me write these out. So equation 1 is going to be 4a minus 2b plus c equals 32. Equation 2, a plus b plus c equals 5. And equation 3, 9a plus 3b plus c equals 17. All right. Okay, guess we should probably review the process as we go along today. With elimination, we need to pick a variable to eliminate. Now, I will tell you, I always eliminate the same variable with these. What's going to be the easiest variable to eliminate?
C.
C. And it's going to be that way in every problem you do, because with it being standard form, it's always going to be a plus C at the end, isn't it? So I personally would be in the habit of eliminating C's. I don't really have a good place to write that, but now, when I go to eliminate C's, if you have an equation that is A plus B plus C, I like to use that to my advantage. Because right now they're all plus C plus C plus C, yes?
Yes.
Pick one of your equations and multiply it by a negative 1. Okay, and I would use that with both of the other 2 equations. Now, my preference on something like this, I like to take this A plus B plus C equation and multiply it by a negative. Not that you have to. Just pick one you want to multiply by a negative, and we'll put it with both the others. Okay? So, I personally am going to multiply number 2 by a negative 1. So I'm going to use equations 1 and 2 right now. Equation 1 is going to stay 4a minus 2b plus c equals 32. Equation 2, if I multiply that by a negative, negative a minus b minus c equals, don't forget to change the sign, negative 5. My C's have opposite signs, so of course I am adding them, correct? So if I add them, let's see, what do we have? 3a, 4a plus negative a is 3a. Negative 2b plus negative b, minus 3b. Positive c and negative c, of course the design is to cancel. Equals 32 plus negative 5, 27. I personally am going to call that equation 4. Repeat the process, except instead of using 1 and 2, I personally would use 2 and 3. Again, it's your pick, right? I would use whichever one you multiply by a negative with the other equation you haven't touched yet. So I'm going to use equation 3 which is 9a plus 3b plus c equals 17. And then when I multiply equation 2 by a negative, it was at negative a minus b minus c equals negative 5. And then those equations are ready to add. So that was using equation 3 and equation 2. So for me, 9a plus negative a is 8a. 3b plus negative b, 2b. C plus negative c cancel. 17 plus negative 5, 12. And I'm going to call that equation 5. Okay, I'm going to put my 4 and 5 together down below here so we can come up with a plan. Well, and I don't know. Here's 4. Here's 5. Thoughts on what you want to do with 4 and 5? Actually, okay, here I'm going to write them with each other. So 3a minus 3b equals 27, and 8a plus 2b equals 12. There's a couple different directions we could go here. We need to eliminate something, yes?
2, 3, 4.
Do what?
3, 4 for these.
You don't mean 3 and 4, though.
3 and 2.
3 and 2?
3 and 2, yeah.
Okay. Now, and I would definitely probably eliminate b's here. If we multiply the top by 2, the bottom by 3, we're going to have 6 b's. Does anyone see anything else? Because I'm going to ask, and I'm not saying you have to go this way. I'm perfectly fine with if we go 6 b's, because that would be what you guys are used to, right? What if, maybe, I'm not sure I'd call it a trick, but there is an option. We've been multiplying equations by stuff, right? These equations both have some GCFs. Is there something we could divide the first equation by and something else we could divide the second equation by? And this might be beyond where our brains are, so I might not use this after.
Oh, 3 and 2?
Okay, do you see that?
I do.
So kind of look ahead, because we can go this direction. Or if I'm going to confuse you, maybe I won't. What happens if I divide that top equation by 3?
Yeah.
You get a minus b equals 9. But the key is that I have a negative 1b, yes? What can I divide the bottom equation by? Everything divides by 2. So then we'd have 4a plus b equals 6. What would be the benefit here? I'd get negative b and a plus b, yes? We'd still be eliminating b's. And the advantage is you work with a little bit smaller numbers than you do bigger numbers. Now, the disadvantage is if I'm losing people along the way. Aaron saw it. Aaron came up with it. Some of the rest of us see it? Or maybe some of us have already jumped ahead and we've already multiplied by 2s and 3s and we're good there. Okay? So, if you see it, I'm going to suggest that we could divide the top one by 3, divide the bottom one by 2. Basically, we're dividing out the GCFs, and in this case, it works. Because my top one becomes a minus b equals 9. My bottom one becomes 4a plus b equals 6. Now, if you're saying, Mrs. Sargent, no, I don't like it. Then, what do you do instead? You go back and multiply by 2 and 3. Okay? So I am set up here because I have negative b and positive b to add. A plus 4a is 5a. Negative b plus b, cancel. 9 plus 6 is 15. If 5a equals 15, what do you know? 15 divided by 5, a is going to be
3.
3. Okay. Am I done?
Nope.
No.
No. Do you know where to go next?
Yep.
Yeah. Once you know 1, in this case we know a, where do we take a?
Back up to 4.
4 or 5 usually, right? Now, and to be honest, we can use the original 4 or 5. You could technically use this 4 or 5 as well after you divide it. What are you guys going to tell me? 4 or 5? 5? So if I use 5, which was 8a plus 2b equals 12, right? Then what do we have? 8 times 3 plus 2b equals 12. 8 times 3 is 24 plus 2b equals 12. To get 2b by itself, I'm going to subtract 24. Wowzers. If you're watching, you might, I just totally,
I saw that. I saw that. I actually didn't say that you did.
well, do me a favor, don't let me proceed by making such a glaring mistake. For those of you who didn't catch, I subtracted 24 on one side, 12 on the other side. Don't ask, I don't know.
Mistake.
You know.
Mistake.
So 24 minus 24 cancels. 2b. 12 minus 24 is negative 12. Divide by 2, and b is
Negative 6.
negative 6. I know a. I know b.
You don't know C.
How do we find c?
Plug it back in.
Plug it into 1, 2, 3. I say I definitely like 2 on this one. So 2 is a plus b plus c equals, was it 5? Yes. So 3 plus negative 6 plus c equals 5. 3 plus negative 6 is negative 3 plus c is 5. If we negative 3, we're going to what? Add 3. And c is
8.
8.
C8, baby. Energy.
Okay. If you altered and went different directions, you got the same answer, yes?
Yep.
Now, here's the question. How do we write our final answer?
ABC.
Y equals 3x squared plus 36x.
Oh, we gotta write the equation. Oh my, get out of town.
Okay, so we're using that form, y equals ax squared plus bx plus c. Now we're going to leave the x's and y's and fill in our ABCs. So y equals 3x squared minus 6x plus 8. So my answers are not ordered triples today. Your answer is an equation. My guess is they're already going to have the y equals, and you just have to write the rest. Okay. Got it? Familiar at least, right? Whether you like it or not, I don't know, but familiar at least. Okay, some of us are working ahead on the next one. Some of us are still trying to get this one down. Questions? Are we good? Okay. You guys have what you need from this screen. You can go ahead and start figuring out how to fill in the next one. Write an equation that passes through these 3 points. So again, I'm going to remind you, I'm going to write it here so I have it as a visual. Y equals ax squared plus bx plus c. First ordered pair we're using, 2, negative 12. And I keep putting the little labels in there, but occasionally we need to know that these are x and y, right? So y equals negative 12 equals a times 2 squared plus b times 2 plus c. So negative 12 equals 4a plus 2b plus c. That's one of my equations. Repeat with your second point. Negative 1, negative 15. So negative 15 equals a times negative 1 squared plus b times negative 1 plus c. Did you do this part right? I know a lot of you are ahead of me. Negative 1 squared is going to be positive 1, yes? So that's still going to be 1a, or a. B times negative 1 minus b plus c. There's equation 2. And final ordered pair, negative 4, negative 90. I will say I'm glad it's the y value that's the big one, because that would be not fun if it was the x value. So y equals negative 90 equals a times x squared, so a times negative 4 squared, plus b times negative 4. Started to write the wrong thing. Plus c. Negative 90 equals, so negative 4 squared is going to be 16a minus 4b plus c. Do your equations match my equations? Okay. So I'm going to go ahead and write mine over here together. For a plus 2b plus c is negative 12. This time it's a minus b plus c equals negative 15. And 16a minus 4b plus c equals negative 90. Those are my equations 1, 2, and 3. What did you eliminate?
C.
Okay. I will eliminate C's. Now, if you're really not liking the C's, B's wouldn't be too bad to eliminate here, would they? Okay. I'm going to stick with C's, just to kind of be consistent there. Right now, they're all plus C's, so I'm going to pick one equation that I want to multiply by a negative. I personally am going to pick the middle one. It's a personal choice. So I'm going to use 1 and 2 to begin with. So 1 is going to stay as is. 4a plus 2b plus c equals negative 12. And 2, when I multiply it by a negative, negative a plus b minus c equals positive 15. Okay. Add them together. 4a plus negative a is 3a. 2b plus 1b is 3b. C plus negative c cancels. Negative 12 plus 15. 3. Now, I'm going to call that equation 4. However, I also see that there's a GCF here. So I can think about, I could, if I wanted to, divide everything by 3 right now. Or I can wait and see what happens. So, equation 4, yes? Okay. That was 1 and 2. What equations are you using this time? 3 and something, yes? Okay. If you're following my lead, I'm going to use 3 and 2. So 3 is 16a minus 4b plus c equals negative 90. 2, negative a plus b minus c equals positive 15. Add 16a plus negative a. 15a. Negative 4b plus b. Minus 3b. C and negative c cancel. Negative 90 plus 15. Negative 75. Okay. And I'm going to call this equation 5. I see a GCF here too. And I don't know if they'll always happen like this or if this is just these are 2 examples I grabbed from the book. Okay. And, oh, they are already, aren't they? We don't even have to, I guess I should look. I'm looking at the fact that, I could divide 4 by 3, I could divide this one by 3. But that's really kind of unnecessary work here, isn't it? Because where we have a plus 3b and a minus 3b. Valid point. Okay, so let's put 4 and 5 together and work the magic. 4 is 3a plus 3b equals 3. 5 is 15a minus 3b equals negative 75. Okay, glad you said something, Landon, because I think I would have done extra work there. Okay?
There we go.
So, 3a plus 15a. 18a. 3b and negative 3b cancel. 3 and negative 75. It's negative 72. We're going to divide. And Landon's telling me negative 72 divided by 18. Should be negative 4. Okay. You got the process down, right? We're going to take A and put it, let me guess, you guys did 4? So if we put that into 4, 4 is 3a, 3 times negative 4, plus 3b equals 3. Negative 12 plus 3b equals 3. Add 12. 3b is 15. Divide by 3, and b is 5. And we know A and B. Pick a way to find C. 1, 2, or 3. Guessing you guys are going to go 2. I'm going to go 2. A is -4 minus B minus 5 plus C equals -15. -9 plus C is -15. Add the 9. C is -6. Okay. Here's a $1 million question. Did you write your final answer? And did you write it correctly? Remember, standard form. Y equals ax squared plus bx plus c. So y equals -4x squared plus 5x minus 6. Okay. The process is there. It's just helping us to build this process, practice this process. If you struggle with it, hopefully it's getting a little bit better for you. Okay. Your homework is in Savas. It's lesson 2.2. Now, I can't remember exactly. Wait, someone tell me, how many questions are there? Are there 12 or are they more? Less? 12? Okay. So I think of those 12, there's maybe 3 of these. Could only be 2. I don't think I would have done 4 of them. But I want to say there's 3 of these. So make sure when you go sit down to do homework, you allow time, yes? Which is why I was trying to suggest you guys might want to start the homework last night. Look at the vertex and whatnot. Okay?